Math. For most games you'll be using a little maths in your code. To code along with this video, open index.html from the folder start lecture 2_11 and also open vec.js from the same folder. First, notice that the vec class has copy, clone, add, sub, distanceTo, angle and angleBetween methods, and we'll review these as they come up in the code we enter. First, we'll create 3 instances of the vec class. The name vec is short for vector. In maths, a vector is simply a value with more than one component. We'll see a lot of vectors over the course. When a value has a single component, it's called a scalar. The vec class has 2 components, x and y, so to create one we use 2 parameters. But if we don't provide any parameters, the constructor code for a vec instance has the default value 0 for both x and y. By adding equals and a value, we can easily add default values for parameters to any function. Here we have the vec instances 0, 0, 4, 0 and 4, 3. If we show these as a diagram, they may be familiar. If you recall your Pythagoras, a popular example is a triangle with one edge of 4 units and another of 3 units. If we square the 4 we get 16 and square the 3 we get 9. Add them together we get 25. Find the square root of 25 and we get the length of the hypotenuse, the longest side, the one away from the right angle. If you recall, the vec3 class has a distanceTo method. The distance from A, 0, 0 to C at 4, 3 should be 5 units. Let's add a console message. We'll use a template string and inside the $curly braces call the distanceTo method. Now check if 5 is the length we get. Save and refresh and we get exactly that. I added to fix 2. This limits the number of values after the decimal point to the value we enter as a parameter. So we get 5.00. Let's take a look at the vec class method distanceTo. First we define a value delta. This is a clone of the vec instance calling the method. Here we have the vec instance A, which has the value 0, 0. Then we use the method sub, which subtracts the past vec. At this stage delta has the values -4, -3. We multiply -4 by -4 getting 16, then add -3 times -3 getting 16 plus 9. I hope you remember that positive times positive is positive, positive times negative is negative, but negative times negative is positive. The value we pass to the math method sqrt, short for square root, is 25, and the square root of 25 is 5. You'll be amazed how often you'll use Pythagoras' theorem to find the distance between 2 objects in a game. The theorem works just as well in 3 dimensions as in 2. Another common problem in games is finding the angle between 2 vectors. If, instead of thinking of B and C as points in 2D space, we think of them as lines extending from the origin, 0, 0, then we can find the angle between them using the math method distanceTo. Again, we'll reduce the precision to just 2 numbers after the decimal point. Save and refresh and we get the angle between vector B and vector C. The code creates 2 angles using the angle method of the vec class. The angle method returns the angle between the vector and the positive x-axis. For B, which is in line with the x-axis, the value is 0, whereas C has the angle 0.6435. You might have been expecting a value around 30 degrees. All math trig functions, and distanceTo is one, return a value in radians. There are 2 pi radians in a full revolution. This is a very important fact, so I'll say it again. There are 2 pi radians in a full revolution. The angle method uses the distanceTo method. This takes the y value and the x value as parameters. The distanceTo method returns a value between -pi and pi. To ensure only positive values, we negate the parameters and add pi to the return value. Now we have two angles. We get the angle between them by subtracting one from the other. We use another math method, ABS. This returns the absolute value. A negative value becomes positive. Then we multiply by 180 and divide by pi to convert the radian value to degrees. So far you've met SQRT, ATAN2 and ABS methods and the constant pi from the math object, and have learned how to find the distance between 2 points in 2D space and the angle between two 2D vectors. Two other methods that are invaluable in games are the sine and cos methods. Notice we have a star displayed. We're going to write some code to rotate this star around in an orbit. To start with, we need a couple of constants and a variable. Center will be the point in the web page that is the center of the orbit. Radius is the distance that the star will be from this center point in pixels. Theta is the Greek word commonly used to represent an angle. We'll initialize it to 0. Now we need to get the star element. It's been given the ID star, so we can use the document method getElementById to access it. Now we need to define a function that will update the value of theta, then calculate where to place the star and set its style values to position it. We'll call it rotateStar. We want this to be called repeatedly, and a great way to do that is to use the JavaScript method requestAnimation frame. This is a built-in function and it will be called around 60 times a second if the browser can keep up. It takes a function that it will call. Here we call rotateStar again. So this function actually keeps calling itself. Now we have a repeating function, we need to update theta by adding 0.05. It will take 100 calls of this function to change theta by 5. And a full revolution is about 2 pi, or about 6.3. If we divide 6.3 by 0.05, it's about 125. So at 60 frames per second, the star will take about 2 seconds, 60 times 2 being 120, to complete an orbit. The x position of the star can be set using the math method cos, which returns the cosine of the past angle. The cosine will return a value between -1 and 1, and we want a value between minus radius and radius, so we multiply the return value by radius, then we add the center x value, and that gives us the x position. When theta equals 0, cos equals 1. Theta equals pi by 2, cos equals 0. Theta equals pi, cos equals -1. And theta equals 3 pi divided by 2, cos equals 0. So the x value slides left until theta equals pi, then slides right until theta equals 2 pi. And this then repeats. The y position is more or less identical, but we use the sine method, not cos. When theta equals 0, sine equals 0. Theta equals pi over 2, sine equals 1. Theta equals pi, sine equals 0. And theta equals 3 pi divided by 2, sine equals -1. Here the y value increases up to pi divided by 2, then decreases down to 3 pi divided by 2, and then increases again up to 2 pi. We can use the calculated values x and y to set the left and top values of the style property of the star element. When setting CSS style values, we need to supply a unit, and here we use px, short for pixel. Add a call to rotateStar to start the loop in action. Save and refresh, and there you have a rotating star. The key uses of maths in your games will be to find distances, angles, and to use sine and cos for smooth movements. Great work! There's just one more thing I'd like to tell you about before we start using the ThreeJS library in earnest, and that is about JSON, a great way in which you can initialize your games. Find out all about it in the next video. See you in a jiffy. This video comes from my Udemy course, The Beginner's Guide to 3D Web Game Development with ThreeJS. Get the full course by following the link at nicklever.com/courses.